to this computer. Good. Okay. Welcome back, everybody. Tonight we want to talk about portfolio optimization, and we are going to pay specific attention how we can do this actually in Excel Solver. But today we are going to focus on the theory behind portfolio optimization. First thing first, what is portfolio optimization? What are we trying to achieve? What's the goal? Selecting the best portfolio from all the possible options while you're juggling between risk and return. You want to balance risk and return. So what is portfolio? Portfolio is simply a basket of investment. Just imagine you have a big, huge basket and you have a little bit of this stock and that stock and this bond and like different things. That's portfolio, yes, a basket of investment. Now, when you have a basket of investment, you have risk, you have return. Now, everybody loves money. Everybody wants to make more and more money. So the goal is to increase the return. But we want certainty, yes? How would you feel if I told you, like, let's say, hey, you won a lottery, you're getting $1 million, yes? You'll be like over the moon, yes? But what if I told you that uh, I'm going to flip a coin? If it turns up to be heads, I'll give you $2 million. If it is tail, I'll give you zero. The expected value is the same, but the second one, oh my God, I cannot sleep until I see that coin. So there are two key concepts that we are going to talk about in the whole presentation. One of them is return, another one is risk, yes? Return measures the average profitability of assets, yes? How much profits that asset can bring for us in, let's say, 1 year. And risk says how sure we are about that profitability. Are we 100% sure or are we 50% sure? What do you think about the historical returns of the stock market? Uh, so historical return of stock markets, uh, it's around like if we go all the way back to 1926 to 2025, so for 100 years, which includes even like 1929 market crash. It's around 12% if we include the dividends, yes? 10% maybe without dividends. So stock market is a good thing. Yes, stock market, we know it gives us a good return. Now, how can we select a portfolio of investment that gives us the maximum return? Yes. So the goal in this action, in this project that we have is to maximize return for a given level of risk. Yes. So I tell you, like your investor, so let's say you have a degree in finance, you have some investors, they tell you that, hey, I'm 72 years old, I don't want to take a huge risk, only 8% risk, and you maximize the return based on the level of acceptable level of risk for them. Or sometimes they tell you that, hey, I just want 10% return, minimize the risk. That's the same thing. So either we want to maximize the return for a given level of risk or minimize risk for a given level of return. It has many applications in different things. So I'm not going to tell you like how to live your lives. Do YOLO, you only live once or not, when you are having fun, when you're consuming. But I'm going to tell you this. Never ever do YOLO when you are talking about investment. Don't say, oh, let's risk it all. Let's see what happens. No, make the financial decisions wisely, make the good money. Then if you want to spend it, go ahead. So personal finance, that's one application. Other applications, institutional investing like hedge funds, pension funds, mutual funds, all of those things. Now, we all have heard of diversification all the time. Yes. What does that mean? Put it simply, don't put all your eggs in one basket. Yes. You have heard of this sentence like 1,000 times. Yes. Spreading investment across different assets that helps reducing risk. Yes. This is something that we are going to talk about over and over in this presentation. How spreading investment across different assets can reduce the risk. Uh, Imagine this, investing 100% of your money in Dogecoin too, because Elon Musk tweeted about that. Is it a good idea? I don't think so. So we want to talk about this. And just even like in terms of eating, imagine if you wanted to eat like pizza for the rest of your life, like the guy in the left. What kind of life that would be? He's not very happy. Look at his face, yes. He even has a little bit of like beard and stuff, yes. But even rather than just pizza, you had a diversified portfolio. Yes, so the left side is single stock investment, right side is diversified portfolio. You could have pizza, you could have also like vegetables and fruits and healthy food. Then you would be handling. Look at him, he's so happy. Yes. Now we're going to make a few assumptions. Number one assumption is that investors are rational and risk averse. So, like when we say risk averse, sometimes people say, oh, if people are risk averse, so why people go to Vegas and gamble and those things? It's a different story. You can't say that. Like, since people are going to Vegas, you go to Vegas, the fun, the fact that the being there and doing the all of those activities, that's like fun for many people, yes. But generally speaking, people, if I ask 100 people like us, and if they want to be honest, most likely all 100 of them would say they prefer $1 million for sure over flipping a coin, 50% chance of $2 million, 50% chance of zero. So we are assuming this. Next one, diversification reduces risk. Again, we are going to come back to this later on. Risk is measured by the variation in return. Yes, that's the definition of risk that we have. Yes. So if you ever forget about this, and just remember this, standard deviation, STDs, we don't like them. We want to avoid STD. Yeah, not the best thing in the world. Now, let's talk about a few. So we are going to get mathematicals a little bit, but hey, it's part of the job, and I'm gonna try to make it fun. I'm gonna try to explain it to the best of my ability. Every now and then, it might get just too much mathematical. Don't worry about it. I promise you this, and if I promise you, never, ever, ever, your employer is going to give you a pen and a paper and ask you to do portfolio maximization, optimization by paper and pen. No, you would do it always on Excel. And the good thing is that Excel has all of these formulas and everything embedded in it. Yes. So all you got to do is to just know the concept, know what is going on, but the mathematics behind it, we don't need it that much. We need some mathematics, but not that much. For expected return, expected returns, first of all, the word expected means we are talking about future. We are not talking about right now. Expected return is weighted average of expected assets returns. Yes. Like if you have two assets, one of them has 10% return and another one has 6%, and you have 50% of your money in one of them, 50% on another, just the average of those two. 10 and 6 average would be 8, yes? So that's going to be your portfolio return. So don't mix two different things. One thing that we have and we talked about was here, where was it? Uh, so return and risk for one specific stock. And then another thing that's the topic of this is risk and return for the whole portfolio. So when I say ERP, it's expected return for portfolio. That P stands for portfolio. So expected return of not only one stock, but the whole portfolio itself. Portfolio standard deviation, that's a Greek letter sigma, yes, lowercase sigma, measures portfolio risk. So not one stock risk, but the whole portfolio's risk using variance of asset returns. And also another thing that we'll be talking about that a lot, covariance between asset returns. So there is a accepted facts in the finance world that there is a trade-off between risk and return. Yes. Yeah, we want to do this balance between risk and expected return. No guts, no glory. If that small cat with the hero like outfit, if he doesn't if he doesn't have the guts to just walk over that bridge, he would never ever go to get to the other parts, yes? And yeah, I made all of this myself. I mean, with help of ChatGPT and asking ChatGPT 10 times, but I made all of this myself. So no gods, no glory. Now, one question that we can always think about is that do you prefer a high risk, high return portfolio or low risk investment with low return? So sometimes people say that, oh, I want high return, low risk. Duh, I wish I had that. But no, out of this, people have different preferences, and there's no right or wrong answer. Some people prefer high risk, high return. Some people prefer low risk, low return. Usually, like something, the trend is that as you get older, you get more conservative. Yes, not only in investment, but fun fact, people get more conservative politically as they get old. On average, not everybody, but on average, that's true. Do you think taking more risk brings more return? It depends. If you go and buy, again, Dogecoin 2 or something, not necessarily, but sometimes it can. And we want to talk about those sometimes. Now, let's talk about mathematics and portfolio expected return. So we are going to be in this together. Portfolio expected return is defined as this. So on the left side, we have E of RP, expected return of the portfolio. On the right side, we have sigma. Sigma simply means sum. It's just sum. And then under the after sum, we have WI. W is weight of one specific stock. So that index I from 1 to n means, for example, you have n different assets in your portfolio. You have a portfolio. Maybe you have, like when we do in Excel, sometimes we have three, four, five, yes? We can't have, unfortunately, like 500 different stocks. We can do that in Python. And if you want, like we can have that in Python as well. I have done the same project in Python, but Excel is good for like five, maybe 10, maybe 20, like something like that. But if it is like 500, it's going to crash. But I is the number of assets that we have in the portfolio. W is weight of each specific assets. And ERI is just the return of that specific assets in the portfolio. So EXP, expected return of the portfolio, N is the number of assets, W is weight of asset I in portfolio, and ERI, expected return of asset I. Now, if I have $100 and I have two stock in my portfolio, $60 one of them, $40 the other one. Now, W1 would be zero point 0.6 and W2 would be zero point 0.4 because $60 is like 60%, yes, I have $100. So W1 is going to be zero point 0.6, W2 would be zero point 0.4. So this is the formula. Let's have a little bit of examples. So for the case of only two assets, that formula would be simplified to this. ERP, we have this WI, ERI plus WB, this, yes. So expected return, so we are not talking about historical return, we are talking about expected return. It's like predicting the weather. Sometimes you're right, sometimes you might be really off, yes? Now, let's do an example. Suppose you have two assets. Two assets, they can be stock, they can be bonds, they can be anything. Asset A, 60% of your portfolio with expected return of 10%. Asset B, 40% of your portfolio with expected return of 6%. What's the expected return of the portfolio altogether? It's this, zero point 0.6 times 10% plus 0.4 times 6%. You do the math, 0.6 times 10 is 6%, the other one is 2.4%. So expected return of the portfolio is 8.4. So expected return of portfolio in just one sentence is the weighted average of different assets in that portfolio, where weights are just uh, how much of your portfolio is devoted to that specific stock. So portfolio return was easy. The whole problem is with portfolio risk and the whole delicacy of this. And the thing we want to do is here. The risk of portfolio, yes, typically measured by standard deviation or variance of portfolio, depends on two things. Number one, the variance or standard deviation of each individual asset, which reflects the asset's own risk. Number two, the covariance. Let's talk about number one a little bit more. Let's say I have one asset like treasury bills. Treasury bills are financial notes, financial assets sold by the Treasury of the United States. They are the most secure assets in the world because the US federal government never goes bankrupt. Even if they don't have money, they can print money, they can create money, and they can pay them back. So it's absolutely risk-free. Or there are some like bonds or stocks that they have very low amount of risk. Let's say something like Coca-Cola. The company has been around for 150 years. It's not going to go that much up or down. However, we have something like maybe, I don't know, Tesla or Nvidia. Those companies, they're very risky, yes. So one item that determines the risk of the whole portfolio, again, when you are managing a portfolio, when you become, hopefully, one day you become a mutual fund manager, or even better than that, hedge fund manager. You become a hedge fund manager, you know what you're doing. In 1 year, you become a millionaire. In 10 years, you become a billionaire. When you become a billionaire, hopefully you would donate $1 million to your professor, but let's see what happens. But in that case, when you are managing a portfolio, you don't care about one specific stock. You care about the whole portfolio's risk. So number two thing that impacts the portfolio's risk is the covariance or correlation between different assets that you have. Correlation reflects how returns of assets move relative to each other. So there are like different cases before getting to matrix form. We are going to have a lot of math here. Just before that, bear with me. So there are different cases. Let's say you have only two assets. Yes, those two assets, price of them can go up and down altogether at the same time, or maybe price of one of them goes up, the price of the other one goes down. Yes. If they go up and down together, then the correlation between them is positive. To be honest, that's a bad thing for the portfolio. We want the we want to bring down the risk of the portfolio. So we gotta look for stuff for assets that if one of them goes up, other one goes down, and they cancel each other. So the volatility of the whole portfolio would go down. But so that's the correlation between different assets. Let's get a little bit mathematical. We have this formula. It's a matrix multiplication. Yes, that's I put that formula over there. Again, Excel would do this for us. I just have it to just have the formula, and then later on when I do uh, the whole operation in uh, Excel, we know this is coming from here. This is coming from here. So W is a column vector of portfolio weights. Yes. So let's say you have three different stocks, stock A, B, C. Now each of them would have a different weight. All the weights together, they must add up to one. Yes, because you want to spend all the money that you have. But let's say point 0.3, point 0.5, and point 0.2. So they add up to 1. W prime is just transpose of that vector. Transpose, so if the original vector is n by 1, it has n rows, 1 column. The transpose is 1 by n. V is the covariance matrix of asset returns. What is that? It's a symmetric matrix, and don't worry about this that much. Yes, again, we are going to use this in practice. That's more important. But it includes two different items. Number one, variance of each specific stock, how volatile each single stock is. Yes. Number two, it includes the correlation between different stocks, if they go up and down all together at the same time, or what's the relationship between each two of them? Yes. So we want to do that. And then portfolio variance is this W prime times the covariance matrix times W. The result, the first one is 1 by n, second one is n by n, the third one is n by 1, and then the last one, so it gets the first number and last number, the result is going to be a single number. So the portfolio variance is not a vector, it's just a single number. So this is again just the formula that we have for the covariance matrix. It's a matrix that we have between all of this stock, and we usually show that with V. It's a square matrix. Its number of rows and columns are the same. On the main diagonal, we have the variance of different assets. So main diagonal starts from top left, it ends at bottom right. We have the variance of different assets, and then we have the covariance of, let's say, different assets on uh, all other uh, points that we have there. Yes. So the diagonal shows is we have n assets and V is n by n matrix. Vij represent the covariance between this. So the diagonal elements, the one on the, they show the variance of each individual asset of diagonal elements. Yes, of diagonal elements, they show the covariance between pairs of assets, a measure of how their returns co-move. Yes, if they move up or down at the same time, that means covariance is positive. Or when one of them goes up, another one goes down, that means covariance is negative. Just keep in mind that we prefer negative covariance. Now, if you have only two stocks, that simplifies to this one. So V is going to be 2 by 2, and the formula is this, yes? So variance of the portfolio itself depends on three things. Weight of each asset, WA, WB, how risky each asset itself is, the variances, and how these assets interact with each other. To give all of them together, they give the total portfolio risk. Yes, so this is the formula, not the matrix format, just the scalar format for the formula. And let's talk about this correlation and what that entails. Uh, the graph on left, that's in green, it has two like variables that they have a positive correlation with each other. So as stock A increases in price, stock B also increases. The second one has zero correlation. They are irrelevant to each other. Stock C, panel C on the right in red, shows two assets with negative correlation. When stock of one of them goes up, the other one goes down. So hopefully we want to find something like this. So this was the example for two assets. Yes, I just copied and pasted from last slide. Let's do just one numerical example, and then we move forward with this. Yes. So if we have like two assets, like like before, A and B, and the weight of A is 60% or zero point 0.6, weight of B is 40% or 0.4. The variance of A is I mean, standard deviation of A is 20, standard deviation of B is 10. And then that one is like correlation coefficient, rho AB. That's correlation. Correlation coefficient is always between -1 and +1. We show that with Greek letter rho, yes? That's always between -1 and +1. Now, let's calculate the whole portfolio's correlation coefficient for these four different cases. When it's negative 0.5, when it's 0, when it's 0.5, when it's 0.95. All we gotta do is to put these five numbers in the formula, nothing else. So easy. So insert, plug in like 0.6 for WA, 0.4 for WB, 20 for sigma A, 10 for sigma B, and then each time we are going to do like a different thing for correlation coefficient. Let's get started with -0.5. In that case, the portfolio's standard deviation is 10.58. As it increases from -0.5 to 0, portfolio risk increases to 12.65. To when it's 0.5, it's 14.42. When it's 0.95, it's 15.85. And it makes sense. when you have two stocks that they are negatively related, yes, one of them goes up, another one goes down, they cancel each other out. So you always have almost same return. Standard deviation of the whole portfolio would be very, very small because you always are getting almost same number. One of them goes up, another one goes down, they cancel each other. But if they move at the same time, so sometimes like one year they move up, you get a very good year. Another they go both down, you get a very bad year. Yes. So it makes sense that so all of them are smaller than now. This is the beauty of this. Portfolio optimization, we want to do diversification. Now look at this. If I wanted to do just WA, remember how we calculated the return for the portfolio? If I wanted to calculate it, if I wanted to calculate the risk for the portfolio with the same formula, yes, WA sigma A plus WB sigma B. In that case, the risk of the portfolio standard deviation would be 16. All of them, all four cases, here is less than 16. So even if you find two assets that they're very correlated, still the risk of portfolio goes down. So we call that miracle of diversification. No matter how you do it, unless if correlation coefficient is 1. 1 means they exactly go up and down at the same time. Put that aside, every other case, it brings down the risk. So just one funny note. If you can find two assets that their correlation coefficient is exactly -1, just please, as a favor to your professor, let me know. And together we can become two billionaires. Yes. I can show that mathematically to you that we actually can become billionaires if we find two assets with correlation coefficient -1. Yes. So if you plug in -1 here for row AB, correlation coefficient, then this plus would just becomes negative, and then this is just -1. So we get to into this formula. And do you remember this from high school? A minus B squared. The answer would be A squared plus B squared minus 2AB. So if you do that, yes, and you plug in WA sigma A for A and WB sigma B for B, that formula just simplifies to this. Variance of portfolio is WA sigma A minus WB sigma B. Now, if we can easily select the ratio of them, WA to WB, in a way that is equivalent to sigma A over sigma B. You do that, your portfolio risk, do cross multiplication, your portfolio risk uh, and okay, I might have a typo over there. I mean, I do have a typo over there. It should be WA over WB equals sigma B over sigma A. Sorry about that. I do apologize, and I'm gonna make a note for myself to correct that. So it's WA over WB equals sigma B over sigma A. So you do cross multiplication. WA sigma A would be WB sigma B, and the uh, the difference between them would be 0. That means your portfolio risk is 0. What does it mean that the portfolio risk is 0? It means that you found risk-free portfolio. It's huge. All you gotta do if their return, which is WA expected return of A plus WB expected return of B, if it is greater than treasury bills return, then that's it. Yes. Uh, then you created a portfolio, a risk-free portfolio with a higher return than the treasury bills. Now, this is such an important topic in investment. I know some people that their whole job, maybe years, 5 years, 10 years, is to find assets with a little bit higher negative correlation. Because if you can find them, you can put them in the same portfolio, bring down the risk, having the same amount of return, boom. Another thing that we usually want to do is Sharpe ratio. The Sharpe ratio measures the excess return per unit of risk. So it's volatility of an investment of the portfolio, yes? So we define it like this: portfolio return minus risk-free return divided by portfolio standard deviation. So on the top, on numerator, we have expected return of portfolio minus risk-free rate. Risk-free rate is like usually 3%, 4% divided by sigma. It means like if I'm bearing one more unit of risk, how much would I be compensated for that extra risk that I'm uh, tolerating? Yes. So the goal in many cases, in many investment projects, the goal is to just maximize the Sharpe ratio. Yes. So let's do a quick example. Suppose risk-free rate is 3%, portfolio return is 8%, portfolio standard deviation is 10. Calculate the Sharpe ratio. The Sharpe ratio is going to be 8 minus 3 divided by 10. So it's going to be half. Yes. As portfolio risk increases, what happens to Sharpe ratio? Does it always increase? No, it depends. Yes, sometimes it goes up, goes down. Uh, Good news. We are done with the hard part of the presentation. Let's talk about what we are going to see later on in Excel Solver and then wrap it up. So what is Excel Solver in the first place that we want to do portfolio optimization using Excel Solver? Solver is Excel add-on. So it comes with, with Excel, but you have to just go somewhere and add it on. Yes. That performs optimization by changing input variables to achieve a desired outcome. So we are going to have some input variables. What are the input variables that we have? Input variables are all those weights, weights of asset A, weight of asset B, weight of asset C. Those are the inputs. We want to play with them to optimize to get the best return for a given amount of risk for the portfolio. It has like many applications: linear programming, nonlinear optimization, portfolio optimization. We are going to focus on the third one. Yes. So if it doesn't come up with your Excel right away, you can easily add it up. Just on a Mac, go to data and then analysis. So go to file, options, add-ins, and then on Mac you can go data, analysis tools, select solver add-in and click go. Yes. And if you get stuck, Google it or ask Chat GPT. Is tell you exactly how to add it on. But yeah, that's like on Mac, do data and then go to tool, analysis tools, and on PC files option adding. So look at these guys. The first guy on the left, he didn't use Excel Solver. He's regretting, he's sweating. The right guy, he's so happy, mostly green. I made it realistic. Like every now and then it's red, it's coming down a little bit, but still so happy. So using Excel Solver or Python, we can also do this project in Python. But whatever we are doing, the whole idea is this. You want to find the optimum set of WI. So let's say you have three stocks, WA, WB, WC, to maximize return for a given level of risk. But that's the whole thing. No matter if you use Excel solver or Python, you can find the optimum set of WI to also maximize Sharpe ratio. So let's have an example of, uh, let me see. Okay, no, sorry. Let's have an example of in Excel solver scenario. You have $10,000 to invest in three stocks. A tech giant, the tech giants like Nvidia or Tesla, high risk, high return. A utility company. Utility companies are usually like very boring but very stable, like something like Coca-Cola. And also ETF. ETF is like when you are not sure, buy S&P 500, buy something like that, yes? The goal is to maximize return while you want to keep the risk below. Oh, yeah, I don't want to cry if I lose everything. So keep this. Solver steps. Number one, so we are going to do all of these steps in Excel Solver. Set up your expected return and risk. Yes. So yeah, we have to calculate these. Expected return first and then, or just return and then risk. That's step number one. Step number two, add the constraint that we have. So we have a few constraints, like I don't want any of these weights to be more than 50%. It's too risky. Or like I don't want to have short selling, so I don't want to have to a negative weights because if you want to short sell, that means negative weights. We don't want that. Or we like just put the conditions there. Click on OK. It's got sometimes it takes like 10 seconds, 15 seconds, and then boom, you got it. Yes. You hopefully you make a profit. How do we do it? There's one variable that you set objective, yes. You set that and then you want to maximize, for example, your return. So here, like R17 that we have, shows the return of the portfolio, for example. Yes. And then by changing what variables? Variables W1, W2, W3. And then you need some conditions. The condition or constraints that you have. Yes. First of all, one condition is that sum of all the weights must be one because you spend 30% on this, 20% on this, 50% on that. They add up to 100%. Another thing you want to have, so this R19, we are going to see that later on. Yes, I'm just giving you an example to just have an idea what's going to happen. And R19 shows the amount of risk. So the whole idea is to maximize return for a given amount of risk. And we are going to do it like over and over again, like 5 times, 6 times to get that curve that we have, like upward sloping curve. It's a beautiful curve. And so that R19 is the risk of the portfolio. We want to keep it under equal or less than 10. We want to maximize R17. That's the return of the portfolio. And we're almost there. So, for example, if we do, this is the screenshot of what we have. Yes, two stocks. Uh, so here we play uh, with the weights of A and B. Yes, five different scenarios. We are given the covariance matrix. You remember this sigma A, sigma B, the 20 and 12. And then we have the return of the portfolio and the risk. But if we have all of this, we want to maximize expected return of the portfolio. Uh, I have another typo here. I meant maximize E of RP. So I'm gonna maximize E of RP, not E of RA. The goal is not to maximize return of asset A. The goal is to maximize return of the portfolio. Given the fact that you want the risk to be less than or equal 12, 14, 16, 18, 20, and you all of that, and you can make this risk return trade-off, and you'll get this curve at the very end. And this shows the risk return trade-off that we talked at the beginning. It's like a roller coaster, yes? Higher risk gives you the potential for higher return, just potential, not always. But sometimes you might prefer merry-go-round, very low risk, stable return. Let's go optimize our portfolios and make it rain. Yes.